Hello everyone. In this session, we are going to learn about exponential distribution. The exponential distribution is a probability distribution that models the time between events that occur randomly. In this presentation, we will explore its definition, application, and parameters. So, definition of exponential distribution. The continuous random variable x has an exponential distribution with parameter beta if its density function is given by f beta is equal to 1 by beta e power minus x by beta, where x is greater than 0, else f of x comma beta is equal to 0. Next, here is an example problem with its solution. Before moving on to the problem, we should know what is the mean and variance of a exponential distribution. That is, mean mu is equals to beta and variance sigma square is equals to beta square. So let's go to the question. Suppose that a system contains a certain type of components whose time in years to failure is given by t. The random variable t is modeled nicely by the exponential distribution with mean time to failure beta is equal to 5. If 5 of these components are installed in different systems, what is the probability that at least 2 are still functioning at the end of 8 years? So here is the solution for this question. The probability that a given component is still functioning after 8 years is given by p of t greater than 8 is equal to 1 by 5 integral limit varying from 8 to infinity e to the power of minus t by 5 into dt. Upon solving this integral, we get e power minus 8 by 5, which is equal to zero point 0.8. That is, the probability that at least 2 are still functioning at the end of 8 years is zero point 0.2. Next is the list of exponential distribution. That is Poisson distribution, Gaussian distribution, beta distribution. Poisson distribution models the number of events that occur randomly over a time interval. The Gaussian distribution models the probability of a random variable taking a certain value. The beta distribution models the probability of a random variable taking a value between 0 and 1. Next, we will see the list of applications of exponential distribution. Reliability and survival analysis, queuing theory, radioactive decay, network traffic analysis, software testing, insurance and risk analysis, epidemiology and public health, inter-arrival times in Poisson process, and project management. Next is the engineering applications of exponential distribution. Reliability testing. It uses exponential distribution to model the failure rates of complex systems and predict when maintenance is required. In engineering, in engineering and reliability studies, the exponential distribution is often used to model the time until failure of a component or system. It helps analyze the reliability and its life expectancy of products and systems. Next is queuing theory. The exponential distribution is used in queuing theory to model the time between arrival of customers or entities in queue. It helps in analyzing the performance and efficiency of queuing systems such as waiting times and queue lengths. Next is radioactive decay. The exponential distribution is commonly used in nuclear physics to model the time it takes for a radioactive nucleus to decay. It helps predict the decay rate of radioactive substances. Next is software testing. It uses exponential distribution to model the time between software failure and predict when updates are required. So next is the network traffic analysis. In network traffic analysis, exponential distribution is used to model the time between data packet arrivals in communication network. Next is parameter estimation, that is maximum likelihood estimation and method of moments estimation. The maximum likelihood estimator for lambda is the reciprocal of the example mean. The method of moments estimator for lambda is the reciprocal of the sample mean. Lastly, we see the quick recap what we have learned in this session. The exponential distribution models the time between events that occur randomly. Its formula and properties were discussed, as well as its application in insurance, reliability, queuing theory, software testing, and some more. Key takeaways: the exponential distribution can be used to find the probability of an event occurring within a certain time interval or to find the amount of time that must pass before an event occurs. Next is the what are the implications. Parameter estimation techniques can be used to estimate the distribution's parameter lambda based on sample data. So this was all about exponential distribution function. Exponential distribution. Thank you.